Hey everyone, welcome back. Today we're talking about database indexing, but not the way you've heard it before. We're not going to be talking about B trees or query optimization theory. We're talking about the mistakes that will actually bite you in 2 years when you're sleeping soundly thinking everything is fine. So let me tell you about a $50,000 mistake. You write your code, you deploy, everything works perfectly, your queries are fast, your users are happy, and 6 months go by. Your user base grows from 1,000 to 50,000 users. Suddenly, every search on your site takes 8 seconds. Your boss calls you into a meeting asking why you need to add 3 more database servers at $500 a month each. That's $18,000 a year in infrastructure costs because you didn't add a 2-line index when you first built the feature. So this is real. This happens all the time and it's completely preventable. So let's start with what you should always index, foreign keys. I'm talking about user ID in your posts table, order ID in your order items table. Every foreign key needs index. There's been no exceptions. Why? Because you will join these tables. Maybe not today, maybe not next week, but you will. And without an index, every join scans the entire table. Imagine you have 100,000 posts in your database. When you want to find all the posts for one specific user, the database has to read all 100,000 rows every single time. So let's look at this query. This might run 1,000 times when someone loads your home page. Without an index, 2.3 seconds. With an index, 0.003 seconds. That's nearly 1,000 times faster. So here's my scar tissue story about this. I once consulted for a startup that was doing a big product launch. They had built this cool new feature that showed recent orders by this customer on every page of their site. It seemed simple enough. Launch day comes, they get 10,000 new customers flooding in. The site completely dies. Completely down. So the problem? No index on the customer ID. In the orders table, every single page load triggered a full table scan to find the customer's orders. 10,000 customers hitting the site meant 10,000 full table scans running at least once. Database CPU hit 100%, site was down for 4 hours during the biggest sales day of the year. That index would have taken 30 seconds to add. Next thing to index, where clauses. Use every single day. Status fields, date fields, category fields. If you're constantly querying where status equals active, or where created at is greater than some date, you need indexes on those columns. Creating these indexes is straightforward. Create index IDX post status on posts, and create index IDX orders created on orders created at. But the question is, why does this matter so much? Let me explain what I call the 95/5 problem. Let's just say you have an e-commerce site. 95% of your orders are completed, 5% are pending. You have an admin dashboard that shows pending orders so your team knows what needs to be processed. Without an index on status, finding those 500 pending orders means scanning all 10,000 orders in your database. Every time someone opens the dashboard, all day long, your support team has this dashboard open constantly, refreshing it throughout the day. I had a client whose admin dashboard took 45 seconds to load, just to show 12 pending orders out of 2 million total records. 45 seconds. The support team would start the page loading and go get a coffee. Now let's talk about what not to index. Low cardinality booleans. Things like is active, that's just true or false, or is premium. Think twice before you index these. So why skip it? If 50% of your users are active and 50% are inactive, an index helps nothing. The database still has to read half your table to find the active users. The index just wastes disk space and slows down every insert and update you do. Now, there is an exception. If it's a 95/5 split and you frequently query the small side, then index it. Like if 95% of your users are free and 5% are premium, and you're constantly querying for premium users, That's worth indexing. So this is where it gets interesting. Composite indexes for common queries. Order matters a lot here. Let's say you constantly run where user ID equals X and status equals pending. You need to index on both those columns, but in the right order. Create it as an index on user ID, status. Not status, user ID. This is critical. So why does order matter? Think of it like a funnel. You want the most selective filter first, the one that narrows down your data the most. If user ID equals 123 narrows your data to 50 rows and status equals pending narrows it to 5 rows, you want to filter by user ID first. Then filter down to the 5 pending ones. If you put status first, the database starts with 5,000 pending orders across all users, then has to find which of those belong to user 123. There's way more work for the same result. I learnt this the hard way. A startup company hired me because their queries were mysteriously slow despite having indexes. They had index created at, user ID for a query that filtered by user ID and sorted by created at, and it seemed logical, right? It took me 2 hours to figure out why it wasn't working. The index couldn't be used for the where clause, only for the sort. So the database was still doing a full scan, then using the index to sort the results. It was basically useless. I flipped it to use user ID, created at. Same index, different order. The query went from 800 milliseconds to 12 milliseconds. Another thing not to index. Every column you might possibly use someday. More indexes do not equal better performance. In actual fact, it equals worse performance. Every index takes disk space, slows down your inserts, updates and deletes, and needs to be maintained by the database. I've seen insert statements go from 5 milliseconds to 80 milliseconds just because someone created 15 unused indexes, just in case. Index intentionally, not defensively. Now for an advanced move that has a huge payoff, covering indexes. Let's say you have a query, select email from users where user ID equals 123. Instead of just indexing user ID, create the index as user ID, email. Why? Because now the database can answer your query entirely from the index without ever touching the actual table. This is called a covering index in an index-only scan. The difference seems small, 0.8 milliseconds down to 0.1 milliseconds, but if this query runs 10,000 times a day, you just saved 7 seconds of database time per day. This adds up when you're at scale. Here's a big one not to do. Text search with like and wildcards, where description like phone. This will absolutely destroy your performance. Why? Because this query cannot use a regular index. It has to scan every single row in your table, every single one. There's no shortcuts. Use full text search indexes instead. MySQL has full text indexes. Postgres has test vector. These are specifically designed for text search and they're incredibly fast. Let's talk about when your index breaks. Your index works great today, but there's a breaking point where it becomes useless. Example 1. Your query changes slightly. You had where status equals active, and it was fast. Then someone modifies it to where lower status equals active to handle case insensitivity. Boom. Index is useless now because you're applying a function to the column. Case 2. Too many results. Your index on category ID works great until your electronics category has 80,000 products. Now it's actually faster for the database to scan the whole table than to use the index and fetch 80,000 rows. So what are the warning signs that you'll have problems in 2 years' time? No indexes on foreign keys, queries that will grow proportionally with your user count, the like search pattern anywhere in production code, no composite indexes for common multi-column where clauses, and indexes on every column just in case. If you see these patterns in your code base, right now, fix them. In future, you will thank you. Here's my simple rule after 25 years. Index columns you filter or join on frequently. That's it. Don't index columns you rarely query. Don't index columns in small tables with less than 1,000 rows. They're already fast enough without indexes. And test everything with explain. Run explain select before your actual query. Look for the seq scan or full table scan in the output. If you see those on the large tables, you need index. If you see index scan, you're good. Use tools to monitor this before disaster strikes. Query logs will show you slow queries over 100 milliseconds, queries that run thousands of times per day, and sequential scans on large tables. Postgres has pg_stat statements. MySQL has slow_query_log. Turn these on. Run explain on your top 10 queries every month. 30 minutes of work that will save you from catastrophe. So here's the final word, and this is what I wish someone had told me when I was 25 years old. Indexes are not about making things fast today. They're about preventing catastrophic slowdowns 2 years from now, when you have 100 times more data and no time to fix it because you're in the middle of a crisis. Your database won't warn you. It won't send you an email saying, hey, you should probably index this. It will just get slower and slower until one day your customers start leaving. Intentionally index, not defensively. Know why you're adding each index, and remember, the best time to add an index was when you wrote the code. The second best time is right now. So, thanks for watching. If this saved you from a future disaster, leave a comment with your own scar tissue stories. I'd love to hear them. And don't forget to like and subscribe. Thanks.